So after that last video, I'm going to do another video. It's a different interpretation of another geometric way or another way of looking at the geometric explanation for the redshift. Okay, so here's you, and here's a bunch of space, the universe, a bunch of space. Okay, so that's, I know it's a little lopsided, but whatever. Imagine it's a sphere or a circle, it's perfect. Anyways, this is some space. Now, you have a certain amount of mass between here and here, between here and here. There's a certain amount of mass. But if the universe is infinite, then outside of that circle, there's an infinity of mass, right? Which is pulling, because it has infinity of mass, at the space near you, trying to pull it towards it, because mass is sort of a relative comparative thing. So what it does is it sort of pulls space outwards like this, and outwards like this, and outwards like this, right? Because of the gravity of the rest of the universe, which stretches this space out a bit. And if you take an elastic medium like this, imagine that was a sheet of rubber, and you could somehow evenly place like a gazillion little tiny clips and then pull all those clips outwards this way, what you would have, of course, is here in the middle, because it's exactly in the middle, doesn't get affected at all. The part closest to the middle gets a little bit affected, and as you go away from the middle, okay, it gets more and more and more and more affected. This part near the edge is extremely stretched out. Ooh, stretched out, huh? That would be from like a higher frequency to a lower frequency. And yeah, so basically there's another sort of geometric or another way of looking at why the redshift can just be a function of just space. It doesn't, this expansion is not at all necessary to have redshift. It is a possibility, but it is not necessary, and certainly not the degree of expansion proposed. That is my opinion. Anyways.